Today we're going to take a look at similar triangles. Similar triangles have the same shape when you look at them, but they're not necessarily same in size. So let's take a look at this similar triangle right here. Notice it's the same shape, but it's smaller in size. Whereas the one on the right, again, is the same shape, but it's bigger in size. So keep that in mind. Same shape, but different sizes. Now let's look at how to label a triangle. We're going to start off with the angles. So this side right here is angle A, angle B, and angle C in the corners. And we write them in capital letters. Now across from angle A would be the side. This would be side A. And we write them in lowercase letters. And let's look at angle B. Across from it would be side B. So we write that in lowercase. And across from angle C would be side C in lowercase. Now let's do the same with the other triangle. We'll label the angles first in capital letters, and the sides will be across from each other in lowercase letters. All right, so now that we've labeled this, let's talk about the special properties of similar triangles, starting with the sides. Now the corresponding sides are proportional. They're not the same, but they're similar in ratios. So for example, notice over here, side C is proportional to side D. Again, different sizes, but they are proportional. So we write them as a fraction, AB over DE. And you can also write it as C over F, because those are the sides as well. Now let's look at side AC. We know it's proportional to side DF, so we can write it this way as well. And last but not least, side BC is similar to side EF. So again, write it as a fraction. Okay, so now that we talked about the sides, let's talk about the angles. Now, the corresponding angles are actually equal. They're not just similar, they're actually equal. So for example, angle A is going to be equal to angle D, and this is how we write it. Angle B is going to be equal to angle E. And last but not least, angle C is going to be equal to angle F. Okay, so let's review this. When it comes to similar triangles, the sides are proportional to each other. So if you look at the actual equation, notice that there are equal signs in between them. What that means is that this ratio here is equal to the second ratio, and it's also equal to the third ratio. So if you recall, similar triangles have the same shape but different size. So for example, one of the triangles can have a ratio of 1 over 2. Even though that's different from 2 over 4, the actual ratio is the same. So in similar triangles, the sides might be different in number, but ratio-wise, they're actually the same, making them similar. Now let's review the angles when it comes to similar triangles. The corresponding angles are actually equal, meaning they are the same. Now when it comes to finding the area, it's a little bit different. The ratio of the areas of the two similar triangles is actually equal to the ratio of the squares of the corresponding side. So it looks something like this. So if you're given an area of one similar triangle, to find the other one, you basically have to take the proportional sides and square them. Now, how did we come up with this equation? This video right here does a good job of explaining it. So if you have time, do watch it, and I'll try to put it in the description box. First question, if triangle BCD is similar to triangle EFG, then determine the value for C and E. So I'm going to start off by writing the equation where I put the sides on top and bottom. So let's start off with this big triangle. So side BC right here is similar to side EF. So I'm going to put BC on top, EF at the bottom. Side CD is basically proportional to side FG. And then side DB is proportional to side GE. Okay, so now let's fill it with the numbers they've actually given us. I'm going to start off with BC and EF. Okay, so BC, the side, is actually 5 centimeters, and the side EF is 4. So I'm going to write 5 over 4. Okay, let's go on to the next one, CD and FG. Well, CD is 10 centimeters, and FG is just E. So I'm going to write 10 over E. And the last one, DB over GE, well, let's see, DB is actually C, and GE is 6. So I'm going to write C over 6. Now, if you notice, all the top numbers are basically from the big triangle, whereas all the bottom numbers are from the small triangles. So when you're making an equation, make sure that numbers from the same triangle are either on top or they're either at the bottom. You don't want to mix them up. Okay, so now let's go on to find side C. we can actually use this equation right here. Even though there's 3 different ratios, we only need 2. So let's write that 5 over 4 is equal to 10 over e. And this is perfect because you only want one variable in your equation. Next, we cross multiply. So multiply the e with the 5, so e times 5 on one side. And let's cross multiply the 4 with the 10, so 4 times 10 on the other side. Now e times 5, that's 5e, and 4 times 10, that's 40. Now let's get rid of the 5 attached to the e, divide both sides by 5, and 5e divided by 5 is e, and 40 divided by 5 is 8. But don't forget the units, it's in centimeters. So side E is actually 8 centimeters. Now let's move on to find what side C is. Now we can use this proportion right here with the 2 ratios. But notice there's 2 variables. We don't want that. We only want 1. But we did find E was actually 8 centimeters. But what if the answer you found was wrong? That would make your next question wrong too. So don't use the 8 that you actually found out. Instead, use the numbers that were actually given to you. So we're going to use 5 over 4 and c over 6. Again, that equal sign means that they're equal in proportion, so we can actually use 2 different ones together. So let's write that 5 over 4 is equal to c over 6. And next, we cross multiply. So we're going to take the 6 and we're going to cross multiply with the 5. So 6 times 5 on one side, and then 4 times c on the other side. Now 6 times 5 is 30, and 4 times c is just 4c. And let's get rid of the 4, divide both sides by 4. 4c divided by 4 is just plain c, and 30 divided by 4 is 7.5, and don't forget units, centimeters. And that right there is your answer. In triangle PQR, side PQ is equal to 8.0 centimeters, side PS is equal to 5.0 centimeters, and side PT is equal to 4.0 centimeters. Now let's start off by answering the first question. Which triangles are similar? So notice we've got this big triangle, triangle PQ and R. And on top of that, we have triangle PS and T. So these two are the similar triangles. So let's write that down. So triangle PQ and R is similar to, and use that squiggly line for similar, to triangle P, S, and T. And make sure that the angles match up, okay? So the corresponding angles should be the same. Now let's determine the length of PR. To do that, we first have to actually label the sides. So side PQ is 8 centimeters. So that would be side from here to here. So that whole side is 8 centimeters. And side PS is 5 centimeters. So from P to S, we know that length is 5 centimeters. And last but not least, side PT is 4 centimeters. So from P to T, it is 4 centimeters. Okay, now that we've got that label, let's actually find the length of PR. So I'm going to start out by writing PR because that's the length I'm trying to find. And if you notice on the triangle, this is where PR is. And the side that's proportional to that is PT. So let's write that at the bottom. Looking at our triangle, the sides from the big triangle will go on top, and the sides from the small triangle will go at the bottom. Okay, let's write our equal sign. Now, the side from the big triangle that they've actually given us a number for is side PQ. And the side proportional to that is side PS. So we're going to write PQ on top, and then PS is going to go at the bottom. So we only need this equation right here to solve the question. So now I'm going to label the actual sides. Again, PR, we don't know what that is, so I'm going to leave it as it is. PT is 4 centimeters, and PQ happens to be 8 centimeters, so let's write that on top. And PS happens to be 5 centimeters, so we're going to write that at the bottom. Next, let's cross multiply. So 5 times PR on this side right here, and then on the other side, 4 times 8. Okay, so 5 times PR is just 5 PR. And 4 times 8, that comes to 32. Now let's get rid of the 5, so divide both sides by 5. 5 PR divided by 5 is just PR, and I'm going to write that on this side right here. So PR is equal to, well, 32 divided by 5 is about 6.4 centimeters, and this right here is our final answer. In this question, triangle ABC is similar to triangle XYZ. And side AC is 6 centimeters, whereas side XZ is 10 centimeters. The area of triangle XYZ is 64 square centimeters, and we need to find the area of triangle ABC. So to start off, we are going to label the sides. Side AC is 6 centimeters, so let's write 6 right over here. And side XZ is 10 centimeters, so let's write 10 centimeters right here. Now they also told us that the area of triangle XYZ is 64 square centimeters. So area is the space inside. So let's write that here. Area of this triangle is 64 square centimeters. Now let's focus on the equation. So area of triangle ABC, because that's what we're trying to find, I'll put that on top, should be proportional to area of triangle XYZ. Now is equal to, let's write the sides. So the next side has to come from triangle ABC, which is this one right here that they've given us a number for. So side AC is actually going to get squared. And side XZ, which is proportional to it, will also get squared. Now that we have those, let's fill in the numbers. Now, area of triangle ABC, we don't know what that is, and that's what we're trying to find out, so I'm going to leave that as it is. Next, well, we know area of XYZ is 64, so at the bottom, I'm going to write 64. Now, side AC is 6 centimeters, so I'm going to write 6, and I'm going to square it. And the bottom part, well, XZ is 10, so we're going to write 10, and we're going to square that. Because remember, for area, you've got to square the sides. Now, area of ABC over 64, let's find the square of 6. So 6 times 6, that's 36. And let's do the same at the bottom. 10 squared, 10 times 10 is 100. Now that we have our equation, let's cross multiply. So on the left-hand side, I'm going to write 100 times area of triangle ABC equal sign, and on the right side, it's going to be 64 times 36. Now I'm going to leave, forgot the triangles, so I'm going to leave the left side as it is, but let's multiply the right side out. 64 times 36 is 2,034, and now let's get rid of the 100 beside the area, so divide both sides by 100. And on the left side, 100 divided by 100 is 1, so you're basically left with area of triangle ABC, and 2,034 divided by 100 comes to about 20.34. But don't forget the units, this is area, so it's going to be square centimeters. And this is our answer.